Hi everyone, my name is Khanh and I'm a developer advocate in the TensorFlow team. So welcome to the workshop on object detection for Android. In this workshop today, you'll learn about how to train your custom object detection model and deploy it to an Android app in just a few lines of code. So in the past 2 years, we in the TensorFlow team has been working really hard with a mission that make machine learning accessible, easy to use for all kinds of developers, including even if you are a web developer or a mobile developer who are completely new to machine learning. We want you to be able to leverage machine learning and add smart features into your product without having to learn any of the machine learning complexities or new techniques, and so on and so forth. So in I/O this year, we released two new machine learning use cases. We support for two new machine learning use cases, which are object detection and audio classification, and make it easy for you to integrate those capabilities into your mobile apps in just a few lines of code. And in this workshop today, we will focus on the object detection use case, and I'll show you how you can train a custom model and deploy it into an Android app in just a few lines of code. So let's start with a few requirements or prior knowledge that you should have in order to get the most out of this workshop. So because this workshop targets mobile developers, you don't need to have any machine learning expertise in order to benefit from this workshop. But because the model training will happen you will write Python code to train a custom model. So having some basic Python knowledge is desirable, but it's not required because Python is a very easy to understand language. And the Python code that we use to train a model is very simple, very easy to understand. So you can just learn it in this workshop. Because we will build an Android app later in this workshop using Kotlin and Android Studio, having some prior experience with Android Studio and Kotlin is desirable. It will need Android Studio 4.1.2 or above to build the app that we will use in this workshop. So if you have an older Android Studio version, please go grab the latest Android Studio and get ready before we start writing code. And finally, you will need an Android emulator or a physical Android device in order to deploy the app that you will build later in this workshop and run it. So the agenda for today, we'll start with a brief definition of what object detection is, and then we will see two approaches to add object detection capability into your mobile app. The first approach is to use a pre-trained model off the shelf and add it without having to train your own model. And the second approach is to train a custom model and deploy it to your app. Then after learning about the theory, you'll spend the majority of time in this workshop to write code, to put what you learned into practice and add an object detection capability into an Android app. And finally, we'll spend a few minutes to recap what we learned in this workshop. That's the end. Okay, so let's get started. What is object detection? Object detection is a computer vision task that analyzes an input image and returns to you a list of known objects and the location of the objects in the image. The location is returned in the form of a bounding box, which is a rectangle surrounding the object. As you can see in this example image here, we have 4 objects in that the model detected from the input image. There's a kite and 3 persons. When talking with developers, especially who are new to machine learning, I often get questions about what is the difference between object detection and image classification. While object detection tells you the location of the objects that it finds in the image in terms of the bounding box surrounding the objects that it detected, but image classification only returns you the list of labels telling you what is inside the image but without the location of the objects. So, for example, in this input image, an object detection can tell you that there are 3 pairs and the location of them. But an image classification only tells you that there's pair in the image without knowing how many of them or where they are. There is another quite common computer vision task that you will see a lot when you work in machine learning. This is called image segmentation. So object detection and image segmentation is similar in the sense that both returns to you where the objects they detect are in the image. But image segmentation is different to object detection, is that it returns to you a mask telling you which pixel belong to which object. So you can see that in this input image segmentation model tells you that here are the pixels belong to the dog, and here are the pixels belong to the cat. Object detection is a very, very powerful computer vision task, and it supports like a lot of variety of use cases, such as detecting empty parking spot or detecting road problems like pothole or road cracks from driving footage. So you will see it a lot in practice. There are 2 approaches to add object detection capability into your app. The first one is to use a pre-trained model of the self, and the second one is to train your own custom model. So using pre-trained model is really useful if you want to detect general objects. So for example, if you want to detect like home goods or food or plants, using a pre-trained model of the self is recommended because it saves you time having to train a model. And if you want to look for a pre-trained model, you can go on TensorFlow Hub, which is kind of like a repository for TensorFlow model, for machine learning model. And you can think of TensorFlow Hub like GitHub for machine learning models, where you can find models from not only Google, but from model publishers from all around the world. And I'll show you how to find models in TensorFlow Hub later in this workshop. But if you can't find any existing model, any pre-trained models that work for your use case, you will need to train your own model. And this is especially necessary when you want to detect objects that are specific to your own domain. So for example, if you want to detect road problems like potholes or road cracks, or if you want to detect food ingredients like cheese, tomato, and so on and so forth. In order to train your own custom model, there are 2 steps that you have to take. The first one is to collect and label your training data. And the second step is to write code to train your model using the training data that you have collected. The first step, collecting and labeling training data, is probably the most tiring part of the whole journey. You can start with like a few hundred images of like photos or images from your own domain, and label the objects that you want to detect from those images. So for example, in this image, I label 4 tomatoes, telling like writing down that there are where the objects are in the image and the label of each object. So to save you time from creating a training data set and get started to learn how to build an object detection model right away, we already prepare a data set that is labeled for you. And in this data set, there are around 100 of food images. And there are 5 different objects already labeled in the image: salad, tomato, cheese, baked goods, and seafood. And we'll use this data set to train a custom model that can detect food ingredients. So the next step after you have a training data set is to write code to train a model. And here are all the code needed to train a custom object detection model. First, you load the data from a CSV file, then customize the model or train the model using your data set. Then you evaluate and see how the model performed against new data it has never seen before. And the final step would be to export it into the TensorFlow Lite format and get ready to deploy it to a mobile app. So either by using a pre-trained model or training your own model, now we have a TensorFlow Lite model that can detect objects. And the final step would be to integrate that TensorFlow Lite model into your app. You can use TensorFlow Lite class library to integrate a TensorFlow Lite object detection model into an Android app in just a few lines of code. You can see that here there's like 3 steps to do that. I will not go into details because we will go into much deeper details later in this workshop and we write this code. So just keep in mind that it's really easy to integrate a object detection model by using task library. Okay, so that's all the theory about object detection on mobile. And now let's start writing code and put them into practice. You can follow the link on the screen here, or you can go on Google and search for TF Lite Object Detection Code Lab, and you will find that this link is the top search result. And this is a code lab that we'll use in this workshop. I will walk you through the code lab and show you how you can integrate, you can train a custom model and integrate it into an Android app. So I'll pause here a few seconds for everyone to either note down the URL or go on Google search and find this code lab. Okay, so let's get started. So if you haven't been able to find the code lab, I don't know if you can see the text, the URL bar here, but this is the link that it will use to find the code lab. You can skip to step 3 because the first 2 steps basically talking about the summary that I have just walked you through earlier. And start with downloading the source code that we'll use in order to integrate this model, in order to get started writing code. And if you click on download source code here, it will take you, it will get you a zip file. Okay, so downloading is happening, and it will get a zip file similar to this one. Let's extract it. We'll get a folder ODML pathway main. Go into it by object detection, and we'll see a folder called Colab2. And then inside it, there's a folder called Android and Starter. So there's 2 folders, Starter and Final. The Final folder is the final app that already have all the code that will need to build in order to do object detection with TensorFlow Lite. And after the workshop, if you want to go back and see like the right answer, you can check out the final app. But we'll start with the starter app and add code into the starter app here. Okay, so once you already have the zip archive and extract it, let's import the starter app into Android Studio. Go to Android Studio, choose Import Project, and go to the folder that you downloaded earlier. So inside the archive, go find object detection, Colab2, Android starter, and click open on the starter folder. Okay, it looks like the app has been imported successfully. The next step would be to run the app on an emulator and get familiar with what it does. So what I have here in this app is basically a very an app skeleton that has 3 images pre-built there for you, so that you can try detect objects from this image later. Okay, you can also take a photo using the app, using the camera app, and then choose it. And you can also try to detect objects from the image that you took with the camera app as well. So this app now it doesn't do anything fancy. It's just like show the photo that you click on the screen, and then we will add code to detect objects into this app. So a few things to get familiarized. You should get familiarized with. There's only one activity in this app, and in the activity, there's a method called run object detection. This is where you will add code here. And this method is called every time you choose a new image or you take a photo with the camera app. And it will be called with the bitmap being the image that you selected or you take photo. And we'll start adding code here to detect objects from the input image. Let's get back to the code lab. And that's all of step 3. Now you already run the app. Let's get to step 4. So in step 4, we will get familiarized with the app. I talked about the run object detection method earlier, and there's 2 more things that you should be familiar with. First is a detection result data class. This is a data class that contains the visualization option that you can call later a method called draw detection result to plot on top of the input image. So let's say that you have an input image like this, and you create a detection result data class that containing the bounding box value, which is 2 coordinates of a rectangle, and a text saying cut 82%. And the draw detection result method, it will put a bounding box on top of the at the location that you specify, and put the text inside the box for you to have it with visualization. And later we will use this method to visualize our detection result. So that's all about like the skeleton app. And now let's get to add a TensorFlow Lite model to detect objects into the app. We'll start with using a pre-trained TensorFlow Lite model that we can download from TensorFlow Hub. You can go to the link here and head to TensorFlow Hub, and you can see that there are several object detection models on TensorFlow Hub that can detect objects from image. And we will use a model called efficient Lite 0. efficient Lite is a family of state-of-the-art mobile object detector that was published by Google, and it can detect object very accurate, but very fast at the same time on mobile devices. And we will use this efficient Lite 0 pre-trained model. You can go ahead and download it from TensorFlow Hub. Or you can also go to the code lab, and I also put a link to download the model from the code lab so that to save you time finding the model on TensorFlow. Okay, so go ahead and download the model. Once you have the model on your local computer, the next step would be to add the model to the starter app. Let me show you how to do it. Okay. Okay, so this is the model that I have downloaded from TensorFlow Hub. I will copy it and put it in the asset folder in my Android in my Android app. So select paste here and name the model model.tflite. Let's give a shorter name. Any name will work. I'll choose model.tflite just to make it short and simple. Okay, so now we have the model here. And the next step would be to add code to use this model. We'll go back to Code Lab and follow the step there, copy the code over to our app. So there's a step to add TensorFlow Lite task vision into the Android app. So let's do it. Go to your Gradle file. You have two Gradle files. One is for your project, and the other one is for the app module. Make sure that you open the app module Gradle file. Go to the bottom and add the dependency here. Okay. So Android still will ask you to sync the project because you just added a new dependency. Click on sync now if you will ask. Great. So next step, let's go to our main activity and add code to the run object detection method to detect objects using the model. The first step is to create an image object. Copy this code over. Now I will explain to you what it is. So Android still will ask you that if I want to import the tensor image class, just follow the succession of Android still and import it. And the first step is to create a tensor image from the input bitmap. Tensor image is the input type for TensorFlow Lite model, and this is basically just take your input image, which is in the bitmap format, and convert it into the tensor image format. Second step would be to create a detector instance, an object detector instance. Copy the code here on Code Lab over to the Android app. Again, Android still will ask you that it doesn't find this object. Just click on import following the succession. So the code here is there's two things. First, we create an object detector option, which contains the configuration for creating an object creating an object detector. There's some options that we set here. Max results mean that the model will detect maximum 5 results from the input image, and it will keep the result that has the highest confidence score and discard like the lower one. And score threshold means that the model will only keep the objects that is more than 50% confident about its detection result, and anything below 50% it was discarded. So it will get back a list of detected objects that has maximum 5 items, and each item will have a score higher than 50%. So after you have the options, the next step would be to create an object detector by specifying the context, then specifying the model file that you want to use to create from, and finally the options that we just created earlier. Okay, and we'll go back to CodeLab for step 3. So in step 3, we will call detector.detect and put in the input image, the tensor image that we converted earlier, and it will get back a list of results showing to you what the model detects from the image. Okay. And finally, we'll write some code to print this result into logcat and exploit. So head over to CodeLab and copy the code over. You see that we call debug print here, but Android Studio will tell you that it doesn't know this method. And just head back to CodeLab and copy the code snippet below it. And put it somewhere in your activity. Okay. First, will ask you to import detection and just go follow this succession. So debug print here takes the input is the results, the detection results from the object detector, and we'll just go through it. It will take the bounding box of each object the model has detected and print out the location of the left top corner and then the right bottom corner. Then it will go through the category or the labels that the model detected and then print it together with the confidence score on how the model is confident about the detection result. So that's all the step needed in order to add object detection capability to this Android app, and just let's run it again and see. Okay, so let's open logcat and filter by OBT, which is the tag that we use to print the detection result. And let's click on an image. Okay, so you can see that here are the detection results that the model have found, the objects the model has found on this image. You can see that there's a pattern box saying that there's a white glass, and the model is very confident about it. So it's probably this one. And it's find a dining table. It's probably like the whole image. There's a dining table in the back. And it finds a bowl. And another bowl. Maybe this one. So we can only like guess now because we haven't visualized the detection result on the image. And let's go one step further. Go back to the CodeLab and go to step 6, and we will update our app so that instead of writing the detection result to logcat, it will draw it on top of the image, input image. And copy this code from step 6 over to replace the debug print code that we had earlier. Don't worry about this issues. It looks like there's some problem with my Android emulator, but it has nothing to do with our app here. And you probably won't see it if you run on a physical device. Okay, let's go to debug print here and replace it with the code that draws the detection result on top of the input image. So you can see that what we do here is we go through each item in the detection result. We take the first category and create a text representing that image. We print out the label of the object, of the detection result, and the score. Then we create a detection result data class and feed it into the bounding box of the object and the text that shows the label and the detection score. And then we call draw detection result with the input bitmap and the list of detection result visualization information. And then we put the input, we put the visualization result to replace the input image on the screen. Now let's run it again and see what we get. So let's click on the same image that we did earlier. And you can see that we get back, yes, that's a white glass. And this is a bowl, it's correct. This is a plate, but for some reason the model thinks that it's a bowl, but it's close. So you can see that with just a few lines of code, we were able to detect objects in the image with pretty good accuracy. But you can see that there's a limitation in using a pre-trained model is that it can only detect like general objects, a dining table. For example, you can see in this food image, it can detect like a dining table, but not like things like salad or cheese or tomato. So in the next step, we'll go and train a custom model that can detect food ingredients and see how the detection result will be different from what we're getting now. So let's get back to Code Lab. Oh, one more thing that I forgot to tell you. You can see that the run object detection method here is called from the default dispatcher using the Kotlin coding library. And it means that the run object detection method is run in the background thread to avoid blocking the app UI. This is because in general, machine learning task is very computational intensive. So you don't want to run them on the main thread because that will block your UI, your app UI while the model is running. So make sure that you always run TensorFlow Lite model on the background thread. Okay. So let's get back to the Code Lab and head to step 7 to train a custom object detection model. We will use Google Colab to train a model. And because training a model is usually takes time, and in this case, we train a salad detector using the data set that I shown to you earlier. It will take about 30 minutes to train the model. And because we don't have enough time in this workshop to train a model live, so I will just walk you through the step required to train a custom object detection model, and you can try it after the workshop by yourself. But for those who don't know what Colab is, this is a website that you can go there and use free GPU from Google to train machine learning models. And we'll start by installing TensorFlow Lite Model Maker, which is a Python library that makes it very easy for you to train custom machine learning models in just a few lines of code. And we import the required package TensorFlow Lite, Model Maker, TensorFlow, and a few more mixed package. And the next step would be to understand the data set. So the data set is provided to you in the CSV format, and we host it in Google Cloud Storage. So that you can see the URL here, start with ZS, semicolon, dash, dash. But you can use a file on your local computer, and that's also fine. And in the CSV file, you will put in let me zoom in a little bit more. And in the CSV file, you will put in one row for each object in an image. So for example, here we have 3 objects. And the first column is the data type. There are 3 data types: training, validation, and test. Training images means that the image will be used to train the model. And validation means that Model Maker will use that image to determine when it should stop training. And test images are not used in the training process, but used after the training to measure how well the model can generalize to the image that it has never seen before. The second column is the path of the image. And here, because we store the dataset on Google Cloud Storage, you see that it has a prefix yes here. But if you use images on your local computer, then it's totally fine. Just put the full path of the image here. Then the next column is the label of that object. We have 5 different labels here: salad, seafood, tomato, baked goods, and one more, I forgot. But basically, just put the label of the object there. And the final numbers are the location of the top right corner and the bottom left. The top left corner is the bottom right corner of the bottom box. So to train your model, the first step would be to choose a model architecture or model specification that you want to use. And when you do object detection model or anything in production, it will always have to trade off between having a more accurate model, but that means that the model may be larger. Usually it will be larger and it will take more computational resource to run it. And that means it will run slower. So in the efficient-depth Lite model family, there are 5 different model types from Lite 0 to Lite 4. And the Lite 4 one is the one that is most accurate, but it's also the most heavy and slow model in the whole family. So you will always need to trade off between accuracy and model size and model speed. So my recommendation is that you experiment with different model architecture and see which one is most suitable for your use case and use it in production. Then you choose a model spec. And in this case, we use efficient-depth Lite 2, which is the middle one. Then you specify the training dataset CSV file and call object detector.dataloader.from CSV, and it will give you back 3 objects: train data, validation data, and test data based on the value of the first column that you define in the CSV. And again, here we use a file on Google Cloud Storage, but you can also use a file on your local computer and just put the path of the file as a parameter. Then the third step is to train the TensorFlow model using the training data. You can see that here we specify a few options. Here's the training data. We specify the model spec. Batch size means that it will take 8 images in one step through the model. And because we have 175 images in the training data set, it will take 21 steps to go through like the whole data set. And validation data means that we will use the validation data to evaluate the model accuracy after each training epoch, which is like one round that uses up the training data. And there's another parameter called train whole model, means that it will try to optimize, model maker will try to optimize the whole model instead of the few layer at the top, so that the accuracy will be able to improve. The expense of the training time can be a bit longer. And you can see that model training goes on here, and it will take about 30 minutes to finish the training. And during the training, you can see that there's several parameters printed out to have you understand how the training goes on. And after the training has finished, you can call model.evaluate with the test data to see how the model performs against data it has never seen before. And there are multiple metrics to measure the model accuracy. And the one that is most used, and it's very common, and you see it in a lot of articles about object detection, is called average precision with intersection on union being 50%. I will not go into details because it will require 10 more minutes or maybe even more to explain what it means. But you can keep in mind that AP50 is a metric that is used to measure object detection model accuracy, and it's and in this case, it is about 39.6%, which is pretty accurate for a object detection model that runs on mobile device. And the final step would be to export the TensorFlow Lite model. So we train the model using TensorFlow, and we export it into the TensorFlow Lite format to integrate it into our Android app. And step 6 would be to evaluate the TensorFlow Lite model and see its accuracy. And you see that here the model accuracy drops a little bit from about 39.6% to around 35.6%. And the reasons for this drop is that first, we apply quantization when exporting the model into the TensorFlow Lite format. So quantization helps shrink the model size by 4 times, but at the expense of some accuracy drop. And there's another thing, is that the way that TensorFlow Lite model process the output of the detection is a little bit different from TensorFlow Lite. And TensorFlow Lite use a less accurate but much faster way to post-process the output. In the machine learning terms, it's used a different non-max suppression algorithm for post-processing. So it's less accurate, but it's it's much faster than TensorFlow, because we run it on a mobile device which doesn't have much computational power to do a complex post-processing algorithm. Okay, so once you have exported the model, the next step would be to download the model and integrate that into our Android app. And because we didn't have enough time to run the training code in this workshop, I already prepared for you the train model that it will get if you run through the code lab. And you can go back to code lab, go to step 7. At the bottom, there's a link to download the stellar detection model that we train, that you can train using this code lab notebook. Okay, now we download the model, and the next step would be to integrate that into our app. So go grab the stellar.tf-lite model that we just downloaded and put it to the asset folder, the same place that we put the pre-trained model that we downloaded from TensorFlow. Okay, and there's only one thing that you need to change to use the new model is that you go to the run object detection method and change the model path. So instead of using model.tflite, which was the model that we downloaded from TensorFlow Hub, you can change that to salad.tflite. And that's it. And we can rerun the app and see the new detection result and see how good it is, like how the new model performed differently to the first model. Okay, so I choose an image here. And one thing to keep in mind is that because we are running on an emulator here, and TensorFlow Lite is not optimized for Android emulator. So you will see that the object detection runs pretty slow on an emulator. But if you are running the same model on a physical Android device, and because TensorFlow Lite is optimized for ARM architecture, and it will run much faster, and you will see the detection result almost instantly. So you can see that the new model now you can detect there are cheese and tomato and cheese from the image, and the detection result is so much different from the general model. And it now can detect food ingredients from the image. And let's see what it detects from this image. You can see that it saw a salad, some cheese, well, a lot of cheese, 4 cheese. And you can see that there's only 5 objects that it picked up. That was because we set the max result to 5 when we initialize the object detector. But if we change that to 10 and also reduce the score threshold so that the model will detect like even the objects that it's not that confident about. And let's see how it will change the detection result that we get back. Let's take a look at the detection result of the same image that we saw earlier. And this time you can see that we pick up many more images. We have cheese here, we have tomato here, and we still have the original salad. So that's it. That's all what you need to train a custom object detection model and deploy it back to the original Android app. And let's get back to the slide and do a quick recap of what we have learned today. So we have seen how to find and download pre-trained object detection models from TensorFlow Hub, and you can just go there, browse other models, and see the different models, the different options that you can get, and integrate that back into your mobile app. And the second thing we learned about how we integrate object detection TensorFlow Lite object detection models in Android app using TensorFlow Lite task library in just a few lines of code. And finally, we learned how to train custom model using TensorFlow Lite model maker, and you saw that it's very easy. So that was it. I hope that you find this workshop useful to give you a introduction about how you can add object detection capability into your mobile apps. You can go to this website, z.go/on-device-ml, to find out more code labs and more training materials on how you can do many different kinds of object detection, many different kinds of machine learning use cases in your mobile app. I hope that you find this session useful, and please enjoy the rest of I/O. Thank you.